Hello everyone. The last video was a refrigeration video for the VRV Amirion line, which had a air handling unit in the penthouse. So that this would be a sequel video to that one where we talk about the air handling unit um, and the airstreams. So over here we had the um, AC coil from those two refrigeration circuits here. And I want to talk about on this makeup air unit how there's two chambers. One is specifically outside air, supply air fans, filter bank, enthalpy wheel. This goes through the AC coil, the sensible wheel, and then it goes off to be supply air for the building. So this will be bringing in fresh air to the heat pump system throughout all the floors of the building. And the return air duct that comes back through will pass through filter bank, your sensible wheel, your enthalpy wheel, your return air fans, and then it's exhausted out to atmosphere here. So quickly, I think the most important thing to talk about is the two wheels here. So we've got the enthalpy wheel and the sensible wheel. The sensible wheel is transferring sensible energy or thermal energy only between the exhaust and makeup air streams. The enthalpy the enthalpy wheel transfers both sensible and latent energy. So it adsorbs and releases water vapor as it rotates between air streams, enabling moisture transfer as well as temperature transfer. And I guess it makes it effective for humidity control. So those are the two most important in my opinion, on how we're reclaiming some of that exhausted air here to help treat the incoming air serving the building. So on this drawing, I'm going to go through each chamber and we'll talk about what some of the controls portions are within each. So I will start on the outside air here. So we've got an outside air an outside airflow station, which is basically a large wing that goes across that gets inserted into the ductwork. And the purpose of these, we got 4 of them on this unit. One at the outside air inlet, the exhaust air outlet, one here at supply air serving the building, one here at return air coming back from the building. And the purpose of those is just to be able to monitor whether we have airflow at that point or not. So a control point here on this outside air coming in is an outside air temperature sensor. So that has a probe inside there, which lets our graphic know what that outside air temperature is. It also comes back to this control panel. Right here, we've got a bank of 6 supply air fans that are drawing that outside air in, and then they're pushing through this filter rack. So we've got a differential pressure here. We got a MagnaHelic glass gauge on the side for a visual reading as you're standing in front of the air handling unit. We also have a static pressure sensor as well. So basically it'll have a poly tubing on the inlet side of that filter bank and on the outlet side of the filter bank, so that it notifies when we have a big difference between the two when these filters are plugged up and they got to be replaced. So then they pass through our wheel, our enthalpy wheel. So now on the discharge side of the enthalpy wheel, there is a thermistor which is basically, as shown here, it's a small copper tubing that gets wound across the wheel here as an averaging sensor so that it's uniform throughout the whole airstream, not just picking up top, bottom, or the middle. We wind that kind of like Christmas lights on the discharge side of that wheel to get an accurate temperature. So then we have a control point for the enthalpy wheel supply air temperature, which pulls that from that averaging sensor. Next, we go into our AC coil here, our heat pump coil for our 2 circuits. That'll help temper the air down, the outside air coming in based on what time of the year, whether that's a cooling function or a heating function. Then we pass through that coil, and now we're on to our sensible wheel. So similar to the other one, there's also a thermistor temperature averaging sensor. So again, same as the temperature averaging sensor on this discharge of this wheel, we have the same here, where it's wound uniformly across the wheel to get that averaging temp. And that gets connected to our supply air temperature on our supply air ductwork serving the building. There's also a supply air relative humidity point within there as well. So then it goes and serves all the floors. Again, it's a heat pump system. So that return air, which gets pulled off of the exhaust, so we're adding air and we're also pulling it away based on the air changes needed. On the return air duct, we have return air relative humidity sensor. We also have a return air temperature sensor, another flow station like we touched on earlier. All right, so our filter rack is here, which will help protect our wheel. We also have another pressure differential Magnehelic gauge on the side. So we've also got that static pressure sensor as well. So we have the visual with the Magnehelic, and we also have the controls component to that as well. We have another averaging sensor on the exhaust air side of the wheel. That gives us our exhaust air temp for the sensible wheel. We also have a relative humidity sensor within that chamber. Now we pass through the enthalpy wheel with another averaging sensor, which gives us our enthalpy wheel, exhaust air temp, and another humidity sensor. And then we've got our fan array here, which is all of our, I think it's 5 return air fans that exhaust it to the outdoors. So all of these points that I have here all communicate back to the control panel on the unit here. So this air handling unit, makeup air unit, comes back to this control panel where it has its own controller. So from that control panel, as far as the BMS goes, we've got a backnet from that unit control panel to the building's BMS system. So that's a Ethernet connection that pulls all these data points from it and takes it over to the house control panel so that it can be added to the building graphics. So this unit is self-sustaining. So based on your airflows and the temperatures, it regulates itself 100%. The graphics are just showing that to the BMS system. So the BMS system doesn't have control of this unit. This project was a really cool one to see built because we had to disassemble the existing one and put this together piece by piece It all had to come in through a doorway. So I had to put it together like Legos just about. So it was neat to see this thing come together. The enthalpy wheel and sensible wheel is really cool technology to help reclaim some of that exhausted air to help treat the incoming air. If you have any questions on this unit, please leave a comment on it and I'd be happy to share. Thank you for watching.